Hello, my name is Jonathan Dowds. I'm a research analyst at the University of Vermont Transportation Research Center, and I'm reporting on a project relating winter severity with snow and ice control costs. This is a project I've been conducting with my colleague, Jim Sullivan, that was championed by Ken Valentine. Historically, planning for snow and ice control activities, and especially budgeting for those activities, has been challenging due to the wide range of winter severity that we see from year to year, and a limited understanding of how quantitatively snow and ice control costs and snow and ice control severity relate to one another. So the purpose of this project was to develop a tool for estimating the cost of achieving the agency's snow and ice control performance targets given a range of weather conditions. The key data sources for the project were the VTrans MATS database, which includes close to a decade worth of snow and ice control costs tracked at the garage level, NOAA weather stations, and ARWA stations maintained by the Agency of Transportation that collect grip data, a proxy for road friction. The first step was finalizing a winter severity metric to use for this project. There have been a number of winter severity metrics related to winter maintenance that have been advanced by different agencies and institutions, and they have varying degrees of usefulness for a project of this type. Specifically, the things that we were looking for is good coverage across the state. We don't want a metric that relies on so many different variables that the data for it can only be collected at a few locations. The weather varies considerably in Vermont from location to location, so we needed a metric that we could calculate across the state with good accuracy and a long historical record. We need to be able to calculate this at the daily or storm level in order to correlate it with the costs that we were looking at, and it needed to be independent of snow and ice control activities. There are a number of agencies that have advanced winter maintenance metrics based on road conditions themselves, but then it's confounded by activities like plowing, which change the road condition without really impacting the severity of the storm, of course. So ultimately, the metric that we settled on was the Accumulated Winter Season Severity Index, or AWSSI, which was developed by the Midwestern Regional Climate Center and which we had explored in a prior project with VTrans. We found that it performed well on the metrics discussed previously and could be calculated throughout the state at high resolution. Our initial attempt to correlate AWSSI and snow and ice control costs looked at these variables on a seasonal basis, and there the correlation was positive as expected. Snow and ice control costs did increase as storm severity increased, but it was also a relatively weak correlation, so we were unable to explain as much of the variability in snow and ice control costs as we would have liked. Ultimately, we looked at aggregating snow and ice control costs and daily AWSSI scores across multi-day storm events. And once we took this step, cost and severity were highly correlated. The R-square for this was 0.74, meaning that the storm level AWSSI was highly predictive of actual snow and ice control costs. This relationship was robust across all of the garages for which we had data and all parts of the state. We're currently looking at a few regional adjustments that may increase that correlation even higher. So the final step for this project is to develop the Excel tool that will allow VTrans staff to input some parameters about the expected winter season, things like the number of storms and AWSSI experience there. We'll provide historical data to give staffers a sense of what would be a typical extreme or light winter at each garage or district. And then the tool will provide a range of estimates of what kind of costs VTrans could expect given that storm severity. We're very hopeful that this tool will give VTrans an added ability to make data-driven decisions about appropriate levels of investment in snow and ice control for upcoming winter seasons, and are excited to bring the final tool to the agency. I'd like to take a moment to thank Ken Valentine and the entire technical advisory committee who have been very active for this project in providing feedback and providing their own expertise, which has allowed us to refine the tool in a number of ways that will ultimately make it of greater value to the agency. So thank you to all of the members of the TAC that have taken the time to provide thoughtful feedback on this. And I look forward to answering any questions that the group may have.